here's your second example of this double replacement reactions predicting their products. Again, this one's going to go a tiny bit faster since we got you through your first one. We'll use the same 3 steps every time. Let's just take the second one off this page, because why not? Although, can I do something more interesting to you? Probably. I can probably do something more interesting to you. Okay, let's take 4. 4 is going to be a little bit trickier. Yeah, that's correct. 4. Okay, so this is going to be number 4. We've got some BaCl2 plus some barium chloride. Some kids just sound that one out, but H3PO4. You may be asking yourself the question, what is up with that AQ? We haven't covered that yet, but here's your, I don't know if I want to get into that right now, frankly. We're gonna conquer that tomorrow. How's that sound? We'll do a whole lot more with that tomorrow. For now, we're gonna say that stands for aqueous, which means, Spanish speakers out there, aqueous, aqua, kind of sounds like agua. That means this compound is dissolved in water. Anything aqueous is dissolved in water. That's all. So actually, if you look through this page, you're going to see that this is an attribute of double replacement reactions. Virtually always, I think actually, always, they occur dissolved in water. For example, the ocean, or your blood, or all sorts of other things. There's a lot of aqueous solutions out there in the world. Yeah, cool. Okay, so for today, just take all those little AQs and be like, we're going to deal with that tomorrow. We do not need to deal with that today. Goodbye. Okay. What we are doing today, though, we are doing this predicting products business. So off we go. First step is to say that is a metal, that is a non-metal. You're thinking about where they live on that table. Doop-a-doop. Barium lives over there. That's how I knew it was metal, by the way. There's your dividing line. Anything over here is a metal. Anything over here is a non-metal. If you're right on the staircase, you're a metalloid. Anyways, okay, so barium is over here in the metal department. It's in the second column. Everything in that second column is always a +2. Barium has got a charge of +2. All right. Chloride's over here in this column, in the halogens column. Chloride's a halogen. Every single halogen has a charge of -1. You can write that as just a minus, you can write a -1, either way is great. Again, we're doing the charge of a single ion here. So even though there's multiples, we don't care. We want to know the charge of a single ion of that type. Okay, so there's our 2 ions. Do the same thing over here. Here you're going to find your hydrogen. I'm just going to put hydrogen on the same table over here. Hydrogen's over here. Oh, well, hydrogen has charge of +1. In your cell phone, the hydroxyl, anyways, you can force a charge of hydrogen to take a different charge, but it's uncommon. In this class, hydrogen's always +1. Phosphate is the anion in that picture. This is actually an acid, by the way, but I'll teach you that later. PO4 has a charge. You can look that up on your polyatomic ions page, the one with all the circles, or you can say, wait a second, I can math this, because you can. You've got 3 hydrogens there. We know that these things are gonna be neutral. They're gonna add up to 0. 3 minus something equals 0. 3 minus 3 equals 0. You can also check that on your polyatomic ions page. Phosphate does indeed have a charge of -3. Okay. Step 1 done. Again, that is sometimes the trickiest step, figuring out the charge of each ion. In step 2, you're going to double replace. So the first thing over there is going to go bond to the last thing over there. You're going to have some barium. That's going to go bond with some phosphate. And in the middle, things are going to stick together. So you're going to have some hydrogen. Remember, the charge is your key to this whole deal, so do keep the charges. Hydrogen's going to go stick to the chloride. Chloride has a charge of -1. Chloride has a charge of -1. Great. All right, so we did our first step, find the charge of individual ions, did the second step, double replace. Last step, write that product as a neutral compound. Here's a little bit more math. Barium starts as +2. Phosphate starts as -3. How many bariums do you need to neutralize your phosphate? Okay, I need 1, 2, 3. We need 3 bariums to neutralize 2 phosphates. 2 polyatomics. Since we need 2 of them, put the polyatomic in parentheses. So multiple polyatomics, get parentheses and a subscript outside showing you how many of that polyatomic you just used. So 2 phosphates looks like that. Over here, we've got a +1, -1. That's neutral. 1 H+ neutralizes 1 chloride. That's neutral compound. +1, -1, done. Yeah. There's a chance that you are noticing that this reaction is not balanced, and I agree with you. We just pulled some stuff out of thin air. We started with 1 barium, now we have 3. We started with 2 chloride, now we have 1, 3 hydrogen. This is not a balanced reaction. And you are correct. It is not a balanced reaction. Reactions like this that show you what you have but are not balanced are called skeleton reactions. And they're completely acceptable in this particular context. When you are doing double replacement, predicting products, I predict that you will be writing always skeleton reactions. If you like the logic challenge and you're like, or if you want your reaction to be balanced and you want to figure out the coefficients and balance your reactions, go for it. There's a pattern. You're going to enjoy the pattern. It'll be great. If that does not suit your fancy, totally fine. Skeleton reactions for this kind of stuff are perfect. Yeah. All right. Yeah, go ahead and jump on the question and answer document, see what you guys are thinking with that, and we'll take it from there. Enjoy.